That's weird.
No way!
How can they be the same length if one of them is a double and the other two are single bonds?
Is it because that
Resonance.
second bond?
The neg.
Okay, Spencer.
It's because, you got organic chemistry, right, Spencer?
Yeah,
It's because of this.
I would have never.
I put the double bond on the oxygen on the left. I didn't have to. I could have put it on the one on the bottom. If it's all right with you, I'm going to leave the lone pairs off. And I also could have put the double bond on the one on the right. These are all just as likely as one another, right?
Yeah.
With the brackets and the negative one sign. And what happens is, the nitrate ion does not choose a double bond on one and a single bond on the other, and then once in a while maybe change. It is going to be, it's going to kind of hybridize this structure and be an actual average of the three. We represent that with double-sided arrows like this. So it's not that there's one double and two singles. It's more like there's 1 1/3 bonds on each. Spencer, go to the next page. That's called resonance. And that's what's going on here. The actual correct dot structure of nitrate has 3 different representations.
We have to make all those?
Yes.
Oh man.
If you're ever asked for a Lewis dot structure, and there could be more than one possible place for a double bond or a triple bond, then you've got to write all the possibilities and connect them with double-sided arrows. Yeah?
What if there's 2 double bonds and 1 single bond?
Won't be.
Oh, well, actually, let me think about that.
That would give the central atom 10 bonds, or 10 electrons around.
Yes.
You're not going to worry about that.
Okay.
Worry about just single and double bonds and triple bonds, and the middle atom only having 8 electrons around.
Are we gonna ever have more than 2 bonds or more than 2 double bonds in a structure?
Possible, yeah, but you're not going to worry about resonance with those.
Okay.
There.
Should we have done the -1 for the ClO4 -1 too?
We did. Yes, we should have, and we did. Now, I want you to especially read the bottom statement down here. That's the justification for when this is analyzed. When we look at nitrate, literally with infrared spectrometer, it will indicate that all 3 of the NO bonds are the exact same length. So it's not one short and 2 long. It's all 3 are the same because of this resonating structure. They find that the NO bond is shorter than a double bond, but it's not as short as a, I said that wrong. It's shorter than a single bond, but it's not as short as a double bond. So that's where we come up with, there's 1 1/3 bonds between all of them. And it's represented like this. We learned about resonance earlier in the year. First chapter of the year.
Isotopes.
No, before isotopes.
Or not isotopes, isomers.
Yeah.
No?
Oh, well then.
Yes! The benzene ring.
Oh.
We talked about benzene looking like this.
Spencer, did you become a genius?
I took organic chemistry for tape
Wait, this year?
right now.
Oh, dang.
Benzene has double bonds alternating. It's not that half the time it's like this and half the time it's like this. It's that all the time it's a hybrid of both of those. So rather than having 3 double bonds and 3 single bonds, all 6 are 1 1/2 bonds. Remember talking about that?
Yeah.
No.
If it were double and single alternating, then some of the carbons would be close together, some of the bonds would be short and some of the bonds would be long around that ring. They're not, they're all the exact same length. That's because of resonance in the benzene ring. So I want you to be aware, if you have more than one place legitimately that a double bond could go, then you're going to write the resonance structures. Spencer, would you go one more slide? Is everybody okay with this slide? JD, hold on a second, Spencer. Does anybody call you Spence?
I rarely hear the word Spencer. Except when you say Spencer, go on.
Because our Spencer, we often call him Spence.
expense?
And if we're mad at him, we'll call him Stencher.
At his expense.
Like he stinks, stench.
That's nice. Whenever my parents get mad at me, they use my full name.
Oh, what's your middle name?
I don't know.
Yes, you do. Oh, that means you never get in trouble. Right?
Yeah.
You
I don't know my middle
When
name
you
because I never
have
got
your
in
house
trouble.
list, you can look at his middle name.
I know I can. I just want to
You
see.
can't look
it.
at my middle name, it's not even on.
Yeah, yours is not on there, is it?
Mine is really bad. because-
Basically, I'm a CIA.
Mine's
Yeah.
more exotic than any of yours.
No, because in Egypt, your
Hi,
dad's
guys.
first name becomes your middle name, so I have an Arabic
Like, put
men's
it that way,
name.
it's
as my middle name.
Well, hey.
Whoever gets
All right, we're good. Let's go to the next one. One more slide. Let's try this exercise and then quit. Would you give the Lewis resonance structure of the nitrite ion? Pretty similar to one that you've seen recently. Go ahead.
At like 10:15, can we like raid Hebble's room and grab some of this?
How else teacher physics this out?
Oh, wait, who's
That's Z-Dan's room.
Oh, it's Ethan.
Davidson.
Yeah. Teacher's name.
Last.
The new teacher.
No, she just changed her last name because she got married.
Did she get married?
Yeah.
Yeah, she was Miss Davidson before.
Oh.
Mrs. Z-Dan now. Last name is Z-Dan. Do you have two different resonance structures?
Oh no.
So here it is before we start making double bonds. But this thing is going to need a double bond in it. Again, that was because nitrogen has 5 plus 2 times 6 is 12, plus 1 more is going to give us 18 electrons in this structure. 2, 4, 6, 8, 10, 12, 14, 16, 18. So I kind of skipped a step there. And if you were watching on the video, you didn't catch that. With all single bonds, we'd have 20 electrons. We can only have 18 though after I count the number from the valence electron. So I had to make a double bond. So this is one resonance structure. What would the other resonance structure look like?
Double bond on
The double bond would be on the right oxygen, not the left one. Oh, that wasn't that hard.
It's never this easy. Not
So that's
never.
resonance. And then you would put a double arrow between like that.
Kyle, what are you doing?
I'm cold.
Any questions about that?
You're in a straight jacket.
All right, let's quit.
It's okay.
Bye.
Yeah.